This is about naming acids and naming bases. So with acids, many people think that this is a covalent compound, so they would do naming of covalent compounds. So therefore, for the first one, you would think this would be hydrogen monochloride. Now, the reason why this is not right, it's because this is actually considered an ionic compound. So all acids and bases are going to be ionic compounds and do not follow the covalent compound nomenclature. Now, just because there's a all non-metal does not mean it's a covalent compound. So let's go ahead and talk about what is an acid. An acid is an ionic compound that contains hydrogen, and it has similar properties with water. And it also has hydronium ion. So that means you have an H plus, where the hydrogen is a positive. And it always is written with hydrogen in the beginning. So if you see something that looks like a covalent compound and it has hydrogen first, you can assume that it's most likely an acid. There are two types of acids. The first type is called a binary acid, and the second type is called an oxyacid. Now, the binary acid is basically what it sounds, a binary, like simple binary. There are only going to be two elements. The first one is always going to be a hydrogen, and then you're going to have a halogen as your second element. So there's always going to be two. So if you guys can think, oxyacid means now you're going to have a hydrogen plus a polyatomic ion. Okay, so it contains three or even more than three types of elements. Now, how do you name these? Well, it's simple. Binary, I will teach you in just a second. And with oxyacid, you really have to look at the name of the polyatomic ion. So you guys have a table in your notes, and I'm going to ask you to go ahead and fill this in. Now, if your polyatomic ion ends with an ATE, you're going to have an ending of ic acid. If your polyatomic ion ends in ITE, you're going to end with us acid. You're like, wait, what do you mean? So let me go ahead in the next slide, show you how to name a binary and then how to name an oxyacid, and we're going to do a couple examples. With a binary acid, you will always have the hydrogen and you will always have a halogen. So here's an example, HCl. So how would I name this? First and foremost, it's really simple. You just need to write hydro, fill in the blank for the name of the halogen, and replace the ending with an ic acid. So since we have in this example hydrogen and chlorine, so we look at the halogen. So this would actually look like hydro. And because the halogen is chlorine right here, I'm going to go ahead and write chlor for chlorine and then replace the ene with ic acid. So this is HCl. Okay? It's as simple as that. Now what we need to learn now is how to write with oxyacid. Previously I said that if the polyatomic ion ends in ATE, we're going to have to change the ending to ic acid. And if it ends with ITE, it ends in us acid. So let's go ahead and look what does this mean. So basically, you don't need to write hydro, okay? Hydro only works with binary acids. When we go with oxyacids, it's just basically the name of the polyatomic ion and change the ending to ic acid or us acid, depending on the ending. So here are my examples. My first example is HNO3 and my second example is HNO2. So we're going to just focus on the polyatomic ion. The first example has a nitrate as the polyatomic ion. So when I write the name for this, I'm going to focus on this part because it's ATE. So how I would write this for the name would be nitric acid. Okay, no hydro, because that's only for simple binary. I just name it by the polyatomic ion. So nitrate turns into nitric, and then I would put acid. This, on the other hand, is nitrite for number 2. Since it ends in ITE, I'm going to focus on this. So now, instead of writing nitric acid, I'm going to be writing nitrous acid. And it's as simple as that. So you have a couple of examples in your packet and also some practice. These should look similar. So I'd like you to go ahead and try these. I have done number 1 and number 3. Try number 2 and 4. And then try the practice problems. You may go ahead and pause here, and then I will go ahead and write the answer on pause, and you can check your answers. I hope you have the same one. Hydrochloric acid for 1, 2 hydrofluoric acid, 3 nitrous acid, 4 phosphoric acid. So go ahead and practice these problems. I believe these are the same number problems that are in your packet. Pause here. Unpause when you are ready. Here are the answers. Check your answers. Ask any questions in class if you have any. And okay, so what about bases? How do we know what a base is? And how do we name them? Well, first and foremost, bases are, again, ionic compounds. And typically the one thing that indicates it's a base is the polyatomic ion, OH-, which is hydroxide. If you see hydroxide, it is a base. So let's go ahead and look at the next one. This is a base, sodium with a hydroxide ion. So the way you would name it is just basically the naming of ionic compounds. Sodium hydroxide, the name of the metal and the name of the polyatomic ion. So what about calcium and hydroxide? Well, again, it would be the name of the metal, which is calcium. Name of the metal, calcium right there. And name of the polyatomic ion, which is calcium hydroxide. So the name, oh, actually it's hydroxide, so the name is calcium hydroxide. And finally, here's one, KOH. Name of the metal, potassium. Name of the polyatomic ion is hydroxide. So the name of this would be potassium hydroxide. Okay, if you have any other questions, feel free to ask in class. But here is how you would do the problems. Thank you.